Alright, this is Ken Rosever, and we're going to talk about probability of union basic. I think I'm trying too hard on these because I just spent a long time working on this. But then I looked back, and because I'm doing these out of order, I realized some of the stuff that I put in the video that I already made for this topic, you would have already learned from previous topics. So, all I really need to tell you here is that you use this formula that I have, and that when the events are independent, it doesn't exclude the possibility that they can overlap. And so for independent events, you'll actually have to calculate this guy at the end, the probability of the intersection. But that's easy because the events are independent. The probability of the intersection is simply the probability of A times the probability of B. So the probability of A is 10% in this problem. The probability of B is 41%. So the probability of the intersection is going to be 0.041. Okay? And so now we just use the formula. The formula says that we go P of A, which is 0.10, P of B, 0.41, minus 0.041, which is very easy to do because we have the Alex calculator available to us. So we'll go there. Calculator, not that we need it because we could probably do this in our head, plus 0.441 minus 0.10 times 0.41. And that answer, 0.0469 in its entirety, we're going to type in here. And then we're going to do the other one. Okay, so going back to here now, when two events are mutually exclusive, it means if one occurs, the other one cannot occur. It's impossible. An example of mutually exclusive is the chance that a pet, is both a dog and a cat. It can't happen. So there's a probability that I walk into a house and a person has a cat. There's a probability that they have a dog. But there's no overlap. There's no probability that they have an animal that is a cat and a dog at the same time. They might have cats and dogs, but that's a separate issue. Okay, so being a cat and a dog at the same time is impossible, right? So that's an example of mutually exclusive. Okay, and when events are mutually exclusive, there is no overlap. So the answer to the union, and you could think of it as a very simple picture with two disjoint circles, where here's A and here's B. The probability of A or B occurring is simply P of A plus P of B. So it's 0.10 plus 0.41. And that's it. So it's 0.51. We don't even need a calculator for that. We just go in here, we type in 0.51, we hit next, and it tells us, very good, practice again. Okay, so I'm going to practice again. We're going to get it added to my pi. So now we have a union again that are independent. When they're independent, it's P of M plus P of N times or minus P of their intersection. So how do we do that? We do the probability for M, which is 0.36, plus the probability for N, which is 0.53, minus the product of their probabilities, which is 0.36 times 0.53. It equals 0.6992. Not a problem. And then the other one is simply the sum of both because, again, it's mutually exclusive. So 0.36 and 0.53 is 0.89. Type that in. Hit next. And in a second, we're going to have this added to my pi. It's going to be awesome. Very good. You seem to have learned it. Yay. So now it's in my pi. That's all there is to that. It's a very simple topic. I hope that was helpful. Bye.